Hello and welcome to Pre-Algebra Lesson 17. And in this video, we're going to talk about integers. Okay, so for our lesson objectives, we want to discover a new set of numbers known as the integers. We want to use the number line to determine the relationship between integers. We also want to learn how to find the opposite of a number. And then lastly, we want to learn to simplify with multiple. And then you see this symbol here. Most of you at this point will know it as the subtraction symbol. Throughout this lesson, we're going to see that symbol used for different things. So I'm just going to put multiple and then show you this on the screen, say symbols. And again, we're going to change the context of that throughout our lesson. All right, so let's begin by talking a little bit about the whole numbers. Now, up to this point, we've only worked with the whole numbers. And typically, these are the numbers you work with in elementary school. We've reviewed how to add whole numbers, and we did that on a number line too. How to subtract whole numbers, again, we did that on a number line. We reviewed how to multiply whole numbers and how to divide whole numbers. And the reason I spent time on that was that if you had forgotten that, when you go to do these operations with integers, you're just going to be behind. So again, the whole numbers start with the number 0 and increase in increments of 1 out indefinitely. So again, remember you'll have these 3 dots here after 3. That just tells you you'd have 4, then 5, then 6. Essentially, that pattern just continues forever. Now, if you look at this illustration here, it's of a number line. And remember, this is just a visual representation of, in this case, it'll be the whole numbers, but in a second, we're going to see that we can draw a visual representation of the integers as well. So look how this is drawn. We have our first notch, or our leftmost notch, occurring where 0 is. And then each notch to the right represents the next whole number, right? An increase of 1. So you got 1, then 2, then 3, and 4, so on and so forth. At some point we stop and we put an arrow there, and the arrow just says that, hey, numbers are going to continue forever, right? And since this is a number line that represents the whole numbers, you can just basically assume that you'd have 9, then 10, then 11, then 12, then 13, then 14, so on and so forth. So every number that is larger than 0 is known as a positive number. We can place a plus symbol, okay, the plus symbol, or you might know it as the addition operator, in front of a number to indicate that it is positive. We don't typically do this because numbers are by default positive when we work with them, right? That's what we're used to working with. So typically you will not put a plus sign in front of it. So for example, if you have the number 3, you would just write it like that. You know that it's positive. But if you wanted to, you could put the plus symbol in front of it to indicate, hey, this is a positive number. This is a positive number, positive 3. So when we encounter a number that is less than 0, okay, less than 0, we refer to it as a negative number, a negative number. So negative numbers always have and again, I talked about this previously in this lesson, this symbol right here, which we've used for subtraction up to this point. So this symbol, we put that sign in front. So if I wanted to, say, write down the number -3, I would put this symbol directly in front of a 3, and I would have a -3. So this is a negative 3. And again, if I wanted to write +3, I just write the number 3, or I could put a +3 in front of it. In this case, that plus is optional. But when you're writing -3, you have to write it. It's not optional because nobody will know that that's a -3. Again, the default value of a number is going to be that it's positive, right? Because that's what we normally work with. So before we move any further, what exactly is a negative number? So some of you might say, well, I don't know what a negative number is. Well, in most cases, all of you have seen some form of a negative number. You might not have worked with them directly in math, but you've seen a negative number before. One thing or one example that's used in almost every textbook would be a negative temperature. So you're watching the weather on TV or maybe on your phone or something like that, and you find out that tomorrow it's going to be, -5 degrees. Essentially, it's colder than 0, right? It's going to be a lower temperature than 0, and they represent that with a negative value, -5. Another common example would be that you have a negative amount of money in your bank account. So let's say you have $5 in your checking account. You go to the store and you buy $10 worth of groceries, okay? Let's say your bank covers the charge. So you had $5, you spent 10. So you're going to end up with negative $5 in your account, plus probably a fee from your bank saying, hey, you spent more than you had. But that's another example of where we would use a negative value. Kind of a sports one that you could think about. Let's say that you're watching a football game and they hand off the ball, running back runs, and he loses yards. Let's say there's a loss of 4 on the play. Well, if you see them represent that with numbers, they're going to say, hey, that's a play that yielded negative 4 yards. So we have negative numbers around us. We don't use them as often as we do the positive numbers, but they are around us. Now let's talk a little bit about 0. So a lot of people get confused about this. They think that 0 is a positive number. It's not. 0 is special. So it is not positive or negative. It is neither. Later on, you're going to hear that 0 is an even number, but it is not positive and it's not negative. Okay, just think about it as being neutral. Okay, so now let's talk a little bit about the integers. Now the integers are important because from here on out, you're going to work with them a lot. So the integers include the whole numbers and their negative counterparts. So we already know what the whole numbers are. Again, I just put that on the screen at the beginning of the lesson. If you look at the integers here, if you just look at this part where it says 0, then 1, then 2, then 3, then comma, dot, 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 that's the whole number part. Okay, this is the part that we know. Whole numbers. Now what we're just introducing is numbers that are to the left of 0. So you kind of think about 1, well, it has a negative counterpart, negative 1. You think about 2, it has a negative counterpart, negative 2. We're just counting like we normally do. We're just counting a different way now. So the numbers are the same. You go 1, 2, 3, 4, 5. You just have negative symbols in front of them instead. So it's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, so on and so forth. All right, so let's take a look at the integers on a number line. So you'll see that 0 is at the center. And then to the right of 0, you have your positive numbers. Okay? And I'm going to put a plus symbol just out here to say that this is positive. So anything to the right of 0 is positive. Anything to the left of 0, you see how we use these negative signs, okay, directly next to the number to say that these numbers are negative. These are negative numbers. Negative numbers. So again, left of 0 is negative, right of 0 is positive, and 0 is neutral, okay? It's neither. Okay, so to understand the relationship between integers, we need to do some extra thinking. So what if I was to ask you, is negative 4 greater than 1? Is that true? Well, in fact, it's not. And what kind of trips people up is they see 4 and they see 1. And they say, well, 4 is a bigger number. Negative 4 is actually a smaller number. As these numbers that are negative get kind of bigger, meaning you have bigger negatives, they're actually getting smaller. And to see why, let's look at a number line. So you remember in the lesson where we introduced the number line, I told you that as we move right on the number line, the numbers are getting bigger. So meaning 1 is bigger than 0, 2 is bigger than 1, 3 is bigger than 2, 8 is bigger than 4, so on and so forth. If a number is to the right of another on the number line, it is bigger. The same is true if a number is to the left of another on the number line, it's smaller. So 5 is smaller than 6 because it's to the left of 6. Or 2 is smaller than 4 because it's to the left of 4. Well, look, as we're moving this way, we're getting bigger and bigger negative numbers. But again, we're moving left, so the numbers are actually getting smaller. And you can kind of think about this using money if you want. I think that's the easiest way to think about it. If I have negative $4 in my account, do I have more money or less money than if I have $1 in my account? What's the relationship between these two numbers? Well, 1 is a bigger number. Negative 4 is going to be less than 1 because in this case, I actually owe $4. Not only do I not have any money, I actually owe $4 to somebody. So I'm in a much worse situation. So this is a smaller value than 1. So we would say negative 4 is less than 1. And if you ever get confused about it, you can think about it in two different ways. The first way is you can do this. You can draw yourself a little sample number line and say, okay, well, where is this on a number line? Where is this? Again, the one to the left is the smaller number. The second thing you can do is kind of use your common knowledge of numbers that you've worked with in the past. So let's say you have two positive numbers. You have 50 and you have 10. So everybody knows that 50 is a larger number. So 50 is greater than 10. But if I put negatives in front of these numbers, this is no longer true. We would have to flip this to in fact get a true statement. Negative 50 is now a smaller number than negative 10 because negative 50 is a bigger negative number. All right, let's look at a quick exercise here. We want to replace each question mark with the inequality symbol less than or greater than. So we're going to start out with negative 2 question mark negative 5. So what's the relationship between these two numbers? Negative 2 is here on the number line. Negative 5 is here. Again, negative 5 is to the left of negative 2, so it's a smaller number. Remember, I told you that the symbol points to the smaller number. So if we look at negative 2 and negative 5, again, my choices would be to use this symbol, which is the greater than, or this symbol, which is the less than. Point the symbol to the smaller number. Negative 5 is smaller, so we use the greater than. Okay, negative 2 is greater than negative 5. And again, thinking about it the other way, negative 2 is to the right of negative 5, so it's bigger. Or again, thinking about it the way I just said, negative 5 is to the left of negative 2, so it's smaller. Either way, negative 2 is greater than negative 5. What about 1 question mark negative 1? 1 question mark negative 1. So 1 on the number line is here. Negative 1 is here. So negative 1 is a smaller number. It lies to the left of 1 on the number line. So we would have 1, and we would have negative 1, and I want to point the symbol to the smaller number. So again, I'm going to use a greater than symbol. Okay, the greater than symbol is going to point to the negative 1. So 1 is greater than negative 1. And again, if you get confused on something like that, just kind of think about money. If I have $1, do I have more than if I owed $1? Well, yes, I do. So 1 is a greater amount. Let's take a look at negative 7 question mark negative 4. So here's negative 7, and here's negative 4. So negative 7 is to the left of negative 4 in the number line, so it's a smaller number. So we would have negative 7 is less than, again, the symbol's going to point to the negative 7 because that's smaller, negative 4. Okay, now let's talk about opposites, which are also known as additive inverses. So opposites are numbers that have the same distance from 0 on the number line, but lie on opposite sides of the number line. So if you kind of think about this, you would have like 1 and negative 1, 2 and negative 2, 3 and negative 3, 4 and negative 4. Basically, it's just the number and then the negative of that number. So you could make an infinite number of these. You can go through and say, okay, 5 and negative 5, 6 and negative 6, so on and so forth. So with opposites, it's a very easy concept. So to find the opposite of a number, we just change the sign. That's all you're doing, because if I say, hey, what's the opposite of 1? Again, you're just looking for that same value, but just with a different sign. So you would just change the sign and say, okay, well, the opposite is negative 1. So we want to find the opposite of each. And again, you might see this in your textbook if you're in pre-algebra. It might say find the additive inverse. Okay, so just know that those two terms are interchangeable. If I say, hey, find the additive inverse, or I say, hey, find the opposite, they're asking for the same thing. All right, so the opposite of 5 is negative 5. Again, all I do is I take the number and I just change the sign. So this is positive, it becomes negative. The opposite of negative 12 would just be positive 12. Again, just change the sign. The opposite of 315 would be negative 315. Again, just change the sign from positive to negative. And then the opposite of negative 1,718,311 would be positive 1,718,311. Very, very easy to find the opposite of a number. Okay, so now we're going to use this concept to actually look at some problems we're going to deal with. So I have here to simplify each, and we start off with something that looks kind of weird. We have what looks like a negative symbol or a subtraction symbol, and then in parentheses we have negative 4. So what does this mean? Well, essentially when you have this symbol directly next to a number, it's saying, hey, this is negative. This is negative. So I would read this as negative 4. When you have this symbol right here, and it's outside of a set of parentheses, basically what I'm saying is, hey, change the sign of whatever's inside of parentheses. But you could read this as the opposite of. The opposite of. So this would be read the opposite of negative 4. And it's just saying, hey, change the sign of negative 4, what would you get? So whenever you see this, what is the opposite of negative 4? It would be positive 4. Again, just as I showed you with these other examples, when I said, what is the opposite of negative 4? We just changed the sign. That's all we're doing here. You just have to know how to read it. The opposite of negative 4 is 4. So that's why we'd write it that way. Now we have the opposite of negative 3. Again, this is the opposite of, and then this is negative 3. And again, all that's saying is, hey, whatever's in parentheses, which in this case it's negative 3, change the sign. So whatever's in parentheses, again, this is negative 3 in parentheses, change the sign, it would be positive 3. Or if you saw a negative symbol outside of a set of parentheses and there was a positive number in there, let's say it was 5, you would just change the sign of 5. Hey, what is the opposite of 5? Negative 5. Okay, that's all you're doing. Okay, so before I kind of get into the next problem, I want to address something that I haven't talked about yet, but it's the concept of an odd or an even number. So I'm going to briefly talk about this. So an even number is a number that is divisible by 2. And when I say divisible by, I mean you divide it by 2 and you don't have a remainder. Okay? So in other words, 6 divided by 2 is 3. So 6 is an even number. Or 10 divided by 2 is 5. So 10 is an even number. 3 divided by 2 would be 1 with a remainder of 1. That would be not an even number. That's something called an odd number. So an odd number is not divisible by 2. Okay, not divisible by 2. 5 is an odd number. 5 divided by 2 would be 2 with a remainder of 1. So that's an odd number. And again, we'll get more into this when we get to the divisibility rules, but you need to have a basic definition of this to apply this trick that I'm going to teach you. All right, so what about when we see a scenario like this where we have multiple symbols in a row? So we have the opposite of negative 15. All right, kind of the slow way to do this is to think about, okay, the innermost set of parentheses contains negative 15. If I kind of move out of that, I would be asking for what is the opposite of this negative 15 here? Well, it's 15, right? Just change the sign. So kind of contained in these parentheses here, I would just get 15 as a result. So I'd have this negative out here, or again, asking for the opposite of, and then I would have inside of parentheses just a 15. Then this negative, or again, asking for the opposite of, is telling me to change the sign of whatever's in the parentheses one more time. So what is the opposite of 15? Well, that's just negative 15. So very, very easy, but if you had a longer problem, it would be ridiculously time consuming. The quick way to do this is just to realize that each time you have a pair of negatives, it's going to make a positive, right? So this one and this one are a pair, so that makes it positive, right? You recall that we ended up with a positive 15 inside the parentheses, right? And then we had the negative out there. Now, there's nothing else to pair up with this, so it becomes negative. So you think about a pair as being 2. So 2, 4, 6, 8, 10, 12. These are even numbers. So when you have a pair, things become positive. So all your problems where you have even amounts of those negative symbols will give you a positive. If you don't have an even amount of those symbols, meaning you have an odd amount of those symbols, you get a negative result. We have 1, 2, 3 of those, meaning we could only make one pair of negatives, and then we couldn't do anything with that one, so we had a negative result. We got a negative 15. If I had the opposite of negative 15 like that, now I have an even number of these symbols. Now I'm going to get a positive 15. So working backwards, this would make it positive 15. So we'd have the opposite of positive 15. And then this would make it negative. So we would have the opposite of negative 15. And then this last one would make it positive again, right? We have another pair. So this becomes 15. So just count the number of symbols that you have. Again, pair them up. So in other words, like this is a pair and this is a pair. So we end up with an even number of those symbols, so we get a positive result. Here's one that's pretty long. So we have the opposite of negative 24. So if you were to kind of work through this the slow way, you'd be like, okay, now this is going to make it positive, this is going to make it negative, this is going to make it positive, this is going to make it negative, This is going to make it positive. You'd end up with positive 24. But the quicker way to do it, again, is just to count the number of symbols you have. You have 1, 2, 3, 4, 5, 6 of them. 6 is an even number. 6 divided by 2 is 3, no remainder. So we know that the answer would be positive. Again, you can kind of also look at it and see, hey, can I pair these up? So this would pair up and become positive. This pairs up and becomes positive. This pairs up and becomes positive. Right? Each pair of those negatives makes a positive. And again, if you kind of look at one, let's say we only had 5. So the opposite of, the opposite of, the opposite of, the opposite of negative 24, like that. Now, this would make it positive. This would make it negative. This would make it positive. And then we'd have one more that would make it negative. So there's only 5. 1, 2, 3, 4, 5. So this would become negative 24 now. Again, it's an odd number. 5 divided by 2 is what? It's 2 with a remainder of 1. So it's not an even number. It's an odd number. So we get a result that is negative. Okay, let's look at one last problem. And look how long it is. So we have the opposite of, 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 the opposite of negative 9. So again, if I could do this the long way, it's going to take some time. So in other words, this would make it positive. This would make it negative, positive, negative, positive, negative, positive, and negative. So we'd have negative 9. Again, the easy way is to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is an odd number. It is not divisible by 2. 9 divided by 2 is 4 with a remainder of 1. So it's an odd number. So that's why we get a negative result. And again, you can also pair them up. You can say, okay, well, this would make it positive. These would make it positive. These would make it positive. These would make it positive. But then this one is hanging out by itself. No other negative to pair with it. So we're going to end up with a negative result. And that's why we have negative 9.